All right, so we're doing ellipses part 2. I just broke it up. I thought it might be nice for you. Ellipses. Ellipses. I can't spell this morning. Ellipses part 2. Okay. I just have one example for you. And the reason I put this problem or this type of problem separate from the others is just because it adds a completing the square element to it. But if you've got yesterday's, you're good to go today. So here's our example. We're going to find the coordinates of the center and foci and the lengths of the major and minor axes of the ellipse. With equation, here we go, equation x squared plus 4y squared minus 6x minus 16y minus 11 equals 0. You probably already know what to do, but I'll help you out anyway. So let's group the x variables together, any variable that has, or any term that has an x variable in it. Leave a little room because I'm feeling completing the square coming on. And then we've got the y's. And then we'll move our constant over to the other side. Alrighty, so let's complete the square with the x terms. We'll turn this into a perfect square trinomial. So that'll be negative 3 quantity squared is 9. So we'll add in a 9 over here. This set here, we need to divide by 4 first. So this becomes 4 times the quantity y squared minus 4y. All right, so let's complete the square with this almost trinomial here. 4 divided by 2 is 2, squared is 4. So that means I'm not going to add a 4. I have to add actually a 16 because of the distributive property. Okay, so this guy factored. And then this guy factored, y minus 2 quantity squared equals, that's 36. Okay, not quite in the ellipse format yet. This, remember, needs to equal 1. So we'll divide everything by 36. So our ellipse x minus 3 quantity squared over 36 plus y minus 2 quantity squared over 9 equals 1. So this is the equation of the ellipse, and this will give us a whole lot of information in order to do what they asked us to do. All right, so our center is located... Center, I'll rewrite it here, x minus 3 quantity squared plus y minus 2 quantity squared equals 1. Now this is an horizontally oriented ellipse. We know it's going to look like this because this is our major axis and it goes with the x coordinate. So we've got a center at 3, 2. A is equal to 6, B equals 3. All right, so they're asking for the center, the foci now. So the foci, remember back that the foci need to have that C value. So we need to look for C. This is where the Pythagorean relationship comes into play. So the distance from the center to the vertex is 3 units, right? I'm sorry. Yes. 6 units. Just kidding. 6 units. I was having it. 6 units from there to there. From the center up to the co-vertex is 3 units. There's 6 there. So we need to go to the focus now. So a squared is equal to b squared plus c squared in this case. So 36 equals 9 plus c squared. Subtract. Let's see, that'll be 727. So c equals 3 square root 3. So this will help us with the focus. So the focus is an x value. So let's take our x coordinate 3 and we'll add 3 square root 3 to it. So plus 3 square root 3. That'll put us right over here. The y value won't change at all. And the other focus, we'll take our x coordinate 3 and we'll subtract 3 square root 3 from it. The y coordinate doesn't change. So this is for our foci. I'll just put a little arrow down here. Those are for our foci. And then it's also asking for the lengths of the major and minor axes, which we already did, but I'll state it explicitly here. Major axis is 6. Minor axis is 3. Doubled, right? We got to double them because it's 6 units from the center over. So this will be 12 and this is 6. All right. I believe that answers all. Yep, that answers all the questions that it asked. So this is how you would find a center, foci, and then your major and minor axes. All right, I hope you find the rest of this section easy. And then I would encourage you to look at the mid-chapter review or the mid-chapter quiz in preparation for our little quiz that will be on Friday. So let's take a look at page 647. And I would like to focus in on just problems 11 through 15. I think that's plenty of practice. It's not a long quiz. It's just a couple questions about circles and parabolas. So 11, they give you an equation, y equals x squared plus 6x plus 5, and you're asked to find the vertex, the focus, the axis of symmetry, the directrix, the direction of opening, and then the length of the lattice rectum. So we first need to change the form that the parabola is written in. Let's go ahead and complete the square with the x terms. So that would be 6 divided by 2. 3 squared is 9, so we'll do x squared plus 6x plus 9 plus 5, and then minus 9 to balance everything out. So then we've got x plus 3 quantity squared minus 4. We know that this opens up because it's positive a, so it opens up. The vertex, the coordinates of the vertex are -3, 4. We are also asked to find the focus, and the directrix. So so remember that the distance, this guy right here is a up front, and it's 1. So a equals 1, and the distance from the vertex to the focus, so here's the vertex, the distance from the vertex to the focus is 1 over 4a. So 1 over 4 times 1 equals 1/4. So since this opens up, our focus is going to be up 1/4. So the focus, the x-coordinate does not change. The y-coordinate is 4 plus 1/4, or 4 and 1/4. The directrix is going to be below the vertex, and it is a y, so I'll write directrix. It is a y equals 4 minus 1/4, or 3 3/4. And then the length of the lattice rectum. So we need 1 over 2a. The length goes 1 over 2a over here. And since a is equal to 1, we've got 1 over, LR. We've got 1/2, so 1 over 2 is the distance from the focus over to the other one side of the parabola. The distance from the focus to the other side of the parabola is 1 over 2 as well. So the length of the lattice rectum would be 1/2 plus 1/2, or 1. All right, so then the next one, number 12, I think we have the other orientation of the parabola. So let's do that one real quick, if you'd like. If not, just turn me off. All right, we've got x equals negative 2y squared plus 4y plus 1. And again, we're going to need to complete the square so that we know where the vertex is located. First, let's factor out the negative 2. So y squared minus 2y plus 1. Divide by 2, squared is 1, but it's not really a 1 because of the distributive property. It's actually a negative 2, so we have to add 2 out here. So negative 2, let's factor this now, y minus 1 quantity squared plus 3. So the direction of opening, this is an x equals, so we know it opens horizontally. It's going to open down because of the negative. So opens down. The vertex is located at, here's our h this time, and then our k is always stuck with the y. So our h is 3, our k is 1. And we're opening down. I'm drawing myself a little picture. So there's my vertex. My focus is going to be below. The directrix will be above. So A equals 2. I'm just using the absolute value. And so the focus, oh gosh, I have it opening down. That's silly. That's not true. It should be opening to the left. There we go. See, I fall apart when I don't have you guys in my life. Okay, so here's our vertex. Our focus is going to be to the left. And the distance, let's remember it's 1 over 4 times a, so 1 over 8. So the focus will be, our x-coordinate is 3. We will subtract 1/8 because we're going to the left. And then our y value will stay the same. So 3 minus 1/8 will give us 2 7/8. So there's our focus. Our directrix is an x equals line. So x equals, we're going to do 3 plus 1/8, or 3 1/8. And then we need to find the length of the lattice rectum, so we need to talk about 1 over 2a. A again is 2. So 1/4 from the focus over to the side of the parabola. And that gives us 1/4, let's see, the length of the lattice rectum is 1/4 in one direction and 1/4 in the other direction. So that gives us 1/2. Okay, so there's the other orientation. Let's see, 13 is a circle problem. So let's take a look at that guy. Find the center and radius of the circle with the equation given. Oh, that's easy. That's easy peasy. So 13, you have a center at 1, 0, and a radius of 3. I don't think that needs to be written down unless you want it. Let me know. I'll be happy to do it. Number 14, write the equation of the circle that has a center at 3, -2, and passes through 3, 4. So this might be a little bit interesting. So 14 has a center at 3, -2, and it passes through the coordinate 3, 4. So we know we have an x minus 3 quantity squared plus y plus 2 quantity squared. We don't know what the r is. That's where we're going to actually utilize the section 1 distance formula. So distance equals the square root of 3 minus 3 quantity squared plus -2 minus 4 quantity squared. So that gives us a distance of -6 squared is 30. So this will be 6. Radius would be, r squared would be 36. So that's 14. And 15 asks you to write an equation for a circle if the endpoints of the diameter are 831 and 3249. Wow, those are big numbers. Okay, so 15, we have the diameter. The endpoints of the diameter are 831 and 3249. So that means to find the center, we've got to find the midpoint. So average of the x's, 8 plus 32 over 2, and the average of the y's, 31 plus 49 over 2. So let's see here, that'll be 40 over 2 is 20. That'll be 80 over 2 is 40. So we know we're going to have x minus 20 quantity squared plus y minus 40 quantity squared, and then we need to find the r. So we can either find the distance between these 2 points and divide it by 2, or find the distance between the center and one of these. I think I'll do the center and one of these maybe. I don't know. I don't know that there's an easier way. Maybe you do. So the distance equals the square root of 8 minus 20 squared plus 31 minus 40 quantity squared. So 8 minus 20 gives us a -12. Squared is 144 plus 31 minus 40 gives us a 9. Squared is 81. So 144 and 81, 225. So that's a radius of 15, squared is 225. So there's our equation. And if you've got those problems, I would say you are good to go for our little quiz on Friday. Have a good day.